Hello and welcome everyone. In this video we are going to look at 10 random questions from matrices from previous year GATE exams. So this is the first question. This is from GATE 2010 exam, and the question says that you have an antisymmetric tensor Pij with these indices I and j running from 1 to 5, and we have to calculate the number of independent components of the tensor. So if you don't know the direct formula, then we know that we can write an tensor in the form of a matrix. So this is an antisymmetric tensor, and the order is 5 cross 5. So this we can write it as a 5 cross 5 matrix, and since it is antisymmetric matrix, so the diagonal elements are all 0, and these elements are related to these elements. So this is a, this is minus of a, b and minus of b, and now we have to calculate the number of independent elements. The number of elements, that if we know the number of quantities, the minimum number of quantities, that if we know, we can write this complete matrix. So if we don't know any element, then we can write all the diagonal elements. These are going to be all 0, and now there are these elements left, the elements above the diagonal and below the diagonal. So the elements below the diagonal are also related to each other. The elements below the diagonal are just opposite sign of just these elements. So the number of independent elements is just these elements, which are, we can calculate these elements or these elements below the diagonal or above the diagonal. So how many elements are above the diagonal, we are going to look at that. So there are 1 2 3 4 5 6 7 8 9 and 10 elements which are above the diagonal, and the elements below the diagonal are also related to these elements. So we need only 10 quantities to write this complete matrix. So the number of independent elements of this tensor is 10, and that there is also a direct formula. You can square the order and subtract it from itself and then divide it by 2. So this also gives the number of independent components. So here we have order 5, so we can write 5 here in the place of n. So it is 5 square 25 minus 5, 20 divided by 2, it is 10. So there are 10 independent elements of this tensor. Now let us look at the next question. We are given a matrix here, and we have to calculate the eigenvalues. So we are not going to calculate the eigenvalues in by writing a characteristic equation of this matrix. We are going to use a trick. We just have to find out which one is correct and which one options cannot be correct. So if we look at the trace of this matrix, it is 5. So the trace of matrix is 5. So sum of all the eigenvalues should be 5. If we look at here, then the sum of all the eigenvalues is 5. So this can be a correct option, and similarly this can be a correct option, but this cannot be a correct option, and also this cannot be a correct option. So the correct option is either A or C. Now we can look at the determinant of this matrix. So if we find determinant of this matrix, let us expand it along the third row. If we expand it along the third row, then the first component of the expansion is 0, the second also 0, and we have the third term only. So it is 1 times 4 minus 9, it is minus 5. So the determinant of this matrix is minus 5. So the product of all the eigenvalues should also come out to be minus 5, so which is only in this case. This one is the correct option. In the next question, we have two matrices A and B, and which are said to be similar if B is written as in this form, where P is an invertible matrix, so we can write P and P inverse both, and B is related to A in this manner. Now we have to find out that which of the following statements is not true. So we know that if A and B are related in this manner, then they have the same eigenvalues. So option D is true. So this cannot be the correct option. This statement is true, so this is not the correct option. Now if the eigenvalues of A and B are same, then their sum should also be same, and then the trace of matrix A and trace of matrix B is also same. So this is also a correct statement. And if all the eigenvalues of A and B are same, then their product should also be same. So determinant of A should be equal to the determinant of B. So this is also true. So the remaining option is this, and that A and B have the same eigenvector. This is not always true, so this is the correct option. And this is the question from GATE 2011 exam. Now the next question is that we have a 3x3 matrix which have elements such that the trace is 11 and the determinant is 36, and we have to find the eigenvalues, the largest eigenvalue of the matrix, and the eigenvalues are given to be positive integers. So now we have to find three numbers that sum is 11 and their product is 36. And so let us divide, let us find three numbers which give out to 36 and their sum is 11. So these two options cannot be correct because all the eigenvalues are positive, and if one of these is an eigenvalue, then the sum of other eigenvalues with these eigenvalues will be greater than 11. So these are not the correct option. And if 9 is a correct option, then 9, if we take the product of other two eigenvalues with 9, so let us suppose the two numbers which give to be 36. So if we multiply 9 by 4, then it is 36. So the product of other two eigenvalues should be 4. Okay, and this is possible in two ways, either 4 into 1, because both are positive integers, so it is either 4 into 1 or it is 2 into 2. So in both the cases the sum is not 11. Okay, the sum of eigenvalues should also be 11, which is not true. So the only option is D option. The eigenvalues should come out to be 6 into 3 into 2. So the sum is 11 and the eigenvalues, the product of eigenvalues is 36. The next question says that we have to find the number of independent components of the symmetric tensor. So in the previous question we had a antisymmetric tensor, and we have here a symmetric tensor, and the order of the matrix is 3x3. So first of all, you can calculate how many independent elements would we need if it were a antisymmetric tensor. So we have the formula n square minus n by 2, n square minus n by 2, and this comes out to be 3 squared minus 3, so it is 9 minus 3, which is 6 by 2, so it is 3. If it were a antisymmetric tensor, we need 3 components, but now we also need the diagonal elements, so it is 3 plus 3, this is 6. So this is the correct option. In the next example, we have to calculate the eigenvalues of this matrix. So you can calculate the eigenvalues by taking by writing down the characteristic equation and then solving it, or we can use we can just eliminate the wrong options. So the sum of eigenvalues should be 0, which is correct in this option. This option B, which is not correct in here, so this can be a correct option, and there is no other correct option because here the sum of eigenvalues is 2 root 2, here it is root 2, here it is 2, and this is only the correct option where sum of eigenvalues is 0 is equal to the trace of the matrix. So this is the correct option. The next question is a numerical answer type question. From GATE 2013 exam, and the question says that this is a matrix and we have to calculate the degenerate eigenvalue of the matrix. What do we mean by degenerate eigenvalue? That this matrix is going to give us 3 eigenvalues. It is a 3-cross matrix, so it is going to have 3 eigenvalues, and either 2 or 3 of the eigenvalues are same, and we have to write down that eigenvalue. So if we try to calculate this the eigenvalues, we can write the characteristic equation that a minus lambda is equal to 0, and then you have here 4 minus lambda, 4 minus lambda, 4 minus lambda, and then you can use matrix operations. You can add here row 2 and row 3, and this will become 2 minus lambda, 2 minus lambda, 2 minus lambda. So you can take out 2 minus lambda, so one of the factor is 2 minus lambda, and then you can also find out that if you expand that matrix, you can expand that matrix or use some other matrix operation. Like if you take out this factor out of this out of the determinant from the row 1, there will be 1 1 1, and you can add this row 1 to this row and this row also, and then you will find that there is a 0 and 0 here, 0 here, and 0 here, and there will be 5 minus lambda here and 5 minus lambda here. So you can take out those factors from row 2 and row 3, so there will be 5 minus lambda squared, and this is 0. So this is the characteristic equation of this matrix. Now the eigenvalues are lambda is equal to 2, 5, and 5, and we have to write down the degenerate eigenvalue. So the degenerate eigenvalue is 5. It is occurring twice. The degenerate eigenvalue is 5. The next question is that you have a matrix A. You are given a matrix A, and you have to find whether it is orthogonal or symmetric or antisymmetric or unitary matrix. So this is a very straightforward, very trivial question, that this is a matrix over the field of complex numbers, and the orthogonal, symmetric, and antisymmetric matrices are defined over the field of real numbers. So only correct option is a D option. In the next question, we have a column vector X that has a dimension n, which is at least 1. Okay, and it has at least one non-zero entry, and the number of, we have to calculate the number of non-zero eigenvalues of this matrix M, that is the product of this column vector and its transpose, which is going to be a row vector. So the product is going to be a square matrix of order n cross n. So this is going to be a square matrix of order n cross n. Okay, so this is M matrix, which is of order n cross n, and this is the x vector, the column vector, and this is a transpose of this vector, which is going to be a row vector. Okay, so now we have to calculate the number of non-zero eigenvalues. So we can calculate it for a trivial example, and that is going to be true for all other options. So let us take that all the elements in this vector are 0 except an element in the, let us say, ith row. Let us say that this is the ith row and the element here is A. So there is a non-zero element in this vector, and this is in the ith row, and that element is going to occur also here in the ith column, and all other elements are 0. So now if you multiply them, then this is going to be a matrix where all the elements are 0 except there is going to be a square if we multiply these matrices, then we will find a square on the diagonal and all other elements will be 0, and this element is going to be the element aii. So this is the only non-zero element here. So this is a M is a diagonal matrix and the eigenvalues will be equal to the diagonal elements. So the eigenvalues are 0 0 0 0 0 and there is only one non-zero eigenvalue, which is a square. So there is only one non-zero eigenvalue, so option C is correct. If we take any other complicated example, that it is also going to give us the same result. Okay, so now the eigenvalues of our Hermitian matrices are all real. We know that the eigenvalues are all real. This is the correct option, and there is no need that the eigenvalues are also positive. So this is only the correct option. A is the correct. Okay, so this is all for today, and see you soon again in the next video.